Hi, we'll explore how box plot is used for outlier reduction, which is one of the data cleaning operation, and to describe the relationship between a categorical and continuous variable. So the box plot can be used outlier reduction for data cleaning process and also to describe the relationship of the continuous and categorical variables. So the box plot is also called as box and whisker plot, which is a standardized way of displaying data distribution based on five summary of statistic. So those five summary of statistics are nothing but the minimum value, which is represented in the box plot as lower end of whisker, and the first quartile or 25th percentile, which is given in the lower line of the box, and the median value, which is mid of the box, the middle line of the box, and the third quartile, which is nothing but 75th percentile of the data, percentile that value of the data, which is given upper end of the box, and the upper end of whisker or maximum value what the data is taking. So this upper end of whisker shows the maximum value taken by the data set, lower end of whisker shows the minimum value taken by the data set, and median value shows the mid value of the data set, and this first quartile or 25th percentile is shows the what is the 25th percentage of the data value, and 75th percentile shows the 70% value of the data value. And as we discussed, any data which is not covered these parameter, the data, any data point which is not covered in these values are called as outlier. For example, here one outlier less than that of lower end of the whisker is displayed. The outlier could be more than that of the upper end whisker. That is also called as outlier. So the value of data point less than lower end of whisker and higher than that of higher end of whisker is called outliers. So those data are not in the group which is called as outlier, which will disturb our analytic process, especially machine learning algorithm performance. Those outliers should be removed before analysis. That means before giving the data to the machine learning model, these outliers to be identified and removed. That is the process what we call it as data cleaning, the process of outlier removal or detection. And these plot is also used to show the relationship between categorical and continuous variable. For our case of data set iris flower, we are going to take the continuous variable of sepal length and the category type of species. We are going to display the relationship between this species type and sepal length. So what type of fish is taking what type of what range of sepal length value that you want to display visually and visualize. So that is the idea of this box plot. So under this box plot analysis, we will take iris data. We want to show the relationship between the category variable of species type and the continuous variable type of sepal length. So that is our idea of this box plot analysis. Let us use this ggplot command in R environment on iris data set, and we'll observe how the plot is produced. So this is the command ggplot. Data set is iris. On the axis space, we use x-axis as a species type, that is categorical variable, and y-axis is the sepal length, the continuous variable. And we want to plot box plot, so we are giving the command geom box plot. We want to make the color is filled by blue and the color of the graph should be black color. So if you run this, already I have run and you can again run, you can see this box plot. So you can see that in x-axis species types is given setosa, versicolor, and virginica. So each category variable, what is the sepal length range value is given here with box plot. For example, if you take Setosa, the very minimal value is here and the median value is 5. So the Setosa flower taking median value of 5 centimeter sepal length, and the maximum sepal length of the Setosa flower is in around 5.8. You can see this is 6, so in around 5.8 it is taking. So Setosa flower can be characterized those flower taking sepal length of maximum of 5.8, medium value of 5 centimeter, and minimum of some 4 point something. Similarly, you can see another species category, versicolor, where the median value of sepal length is more than the Setosa. That is, you can see that it is around 5.9, in around 5.9, right? And maximum value of sepal length is 7. It is taking 7. And the minimum sepal length is equal to more or less the median value of the Setosa, near 5, that is 4.8 maybe. Similarly, Virginica, you can take the minimal sepal length is nearly first quarter of the versicolor category, and the median value of the sepal length is nearly to maximum value length of the versicolor, and the maximum length of the Virginica species is around 8, that is 7.8. So these graph visually shows us these three pieces having different value distribution of sepal length, which can be easily classified under classification problem of machine learning. Suppose these are in the same line, for example, this box, this box, this box are all in the same line, the sepal length is taking more or less same value for all the three category of flower, then it is very difficult to classify the species type by using sepal length. That is the interpretation. But here under this our case, the data distribution of different species of this sepal length is different. It is taking different range of value. For example, the Setosa is taking lowest range values, and versicolor is taking some mid-range values, and Virginica is taking highest values. So because of different distribution value of the sepal length, we can easily classify the flower species type using sepal length. That is the interpretation. That is what you have to interpret from the box plot. So what is the use of this box plot distribution value plotting? We can investigate from the first stage whether this data, whether using the sepal length data variable, can we classify the species type properly or not by means of machine learning algorithm or some data analytic tool. That interpretation we can make from the box graph. For our under our case of the iris species classification problem using sepal length, we can very well do the classification because the data distribution taken is different for different species type. Right? For example, from the graph itself, I can say that any flower taking sepal length of around 6.5 above, any flower that is having sepal length of 6.5 and above is definitely the type of Virginica, because you see that 6.5 is not mostly taken by this other category, right? So we can classify very well. That is the key idea.